The old incandescent bulbs are dead. Today's Christmas is powered by smart LEDs. Lights.
We all remember the struggle. Hot glass bulbs, fragile filaments, and the nightmare where if one went out, the whole strand died.
The secret to the new lights is astonishing. Inside every single bulb is a tiny microchip computer that talks to your phone. It starts with a flexible printed circuit board, a thin ribbon of polyimide film that carries the electrical signals. A robotic printer applies microscopic dots of solder paste, a mix of metal powder and flux, exactly where the components will sit.
The pick-and-place robot is the fastest machine in the factory. It places 36,000 chips per hour, never missing by more than a hair's width.
Next to the chip goes the RGB emitter. It contains tiny crystals of gallium nitride that light up red, green, and blue. The tape travels through a reflow oven. Heat melts the solder paste, creating permanent electrical connections for the tiny components.
An automated optical inspection camera photographs every single bulb. AI software checks for defects faster than any human eye.
Before they are covered in plastic, the naked chips are tested. They must perfectly display pure red, green, and blue light.
The continuous tape is sliced into individual nodes. Each one is now a fully functional, independent smart light.
Meanwhile, the wire is being prepared. Multiple strands of copper are twisted together to ensure flexibility in cold winter weather. The copper is coated in durable PVC insulation, usually dark green to blend in with Christmas trees.
Old lights use 2 wires. Smart lights need 3. One for power, one for ground, and a crucial third wire for data signals.
The wire is cut into precise segments. The machine automatically strips the insulation off the ends, ready for soldering. Robots solder the 3 wires to the tiny circuit node. This is the critical point where power and data meet the chip. To protect the delicate electronics from moisture, the entire node is injection molded in clear, hard plastic. The final outer shell is a frosted plastic globe. This diffuser spreads the harsh point of light into a soft, pleasing glow.
The wired chip is inserted into the outer bulb and sealed shut, creating a rugged, waterproof light fixture.
Bulb by bulb, the strand grows. A standard set might have 100, 200, or even 500 of these smart nodes connected in series.
Every single strand goes to the burn-in rack. They are run at full brightness for hours to ensure no chips fail under heat.
This isn't just for show. The rainbow cycle tests the data transmission. The signal must pass.
Because they are connected in series data, one bad chip can disrupt the pattern. Defective strands are immediately removed. To survive snowy winters, they must be waterproof. Random samples are dunked while active to ensure the seals hold tight.
The strand needs a brain. The controller box houses the Wi-Fi and Bluetooth chips that connect the lights to your home network.
Connectivity is tested. The lights must pair with the smartphone app instantly via Bluetooth before handing off to Wi-Fi.
No more tangles. High-speed winding machines spool the long strands neatly, ensuring they come out of the box ready to hang. They are packed into glossy retail boxes, complete with the power brick and quick start guide, ready for the store shelf.
Production begins in the summer to meet the December rush. Millions of units are stacked and prepared for global shipping.
From the factory floor across the ocean, these containers carry the magic that will light up homes around the world.
At home, the difference is obvious immediately. The neat winding means they are ready to go right out of the box.
Installation is the same as always, but the real magic happens once you plug them in.
With the app, you are no longer stuck with one color. You have 16 million options at your fingertips.
The most advanced systems use your phone's camera to create a 3D map of the lights on your tree, knowing exactly where each bulb is located.
This mapping allows you to literally paint patterns onto your tree. If you can draw it on your phone, the tree can display it.
The controller has a built-in microphone. Switch to music mode, and your tree becomes a synchronized light visualization of your favorite holiday tunes.
Alexa, turn on Christmas.
Integrated into your smart home, you don't even need the app. Just ask Alexa or Google to turn on Christmas.
The technology isn't just for trees.
Permanent outdoor smart lights are becoming popular, used for Christmas, Halloween, and everyday architectural lighting.
Despite all the tech, they use 90% less energy than old incandescent bulbs, saving you money on the holiday electric bill.
And because LEDs don't have filaments to burn out, these strands are rated to last for 50,000 hours. That's decades of Christmases.
To really understand the scale, we have to go back further. The driver chips start on massive silicon wafers in ultra-clean semiconductor fabs.
Diamond saws dice the wafer into thousands of individual microchips, each one destined to control a single point of light.
To create pure white light, blue LEDs are often coated with a yellow phosphor. The combination of blue light and yellow light tricks our eyes into seeing white.
Inside the LED emitter itself, microscopic gold wires are bonded to the crystals at blinding speeds to connect them to the power source.
A clear epoxy resin is poured over the delicate internal wires, protecting them and forming the primary lens that focuses the light.
Not all LEDs are born equal. They are individually tested and binned by color temperature to ensure every light on a strand matches perfectly.
Back in the wire factory, clear PVC pellets are mixed with specific green pigments to achieve that classic Christmas wire color.
The wire must be strong enough to withstand being pulled through trees and wrapped around banisters without snapping the internal copper.
The cold bend test ensures the PVC insulation doesn't become brittle and crack when you're hanging lights in freezing December temperatures.
For outdoor lights, UV stabilizers are added to the plastic so the green wire doesn't turn bleached white after a few seasons in the sun.
All this technology comes at a price. A smart strand can cost 20 times more than a traditional set of dumb lights.
And because they contain complex circuit boards and soldered chips, they are much harder to recycle than simple copper wire strands.
But for those who miss the old days, these lights can perfectly mimic the warm, cozy glow of vintage incandescent bulbs, just without the heat.
LEDs are just the current step. The future might hold holographic projections or wireless power that eliminates strings entirely.
It's a Silicon Valley Christmas. The same technology in your phone is now hanging on your tree. Billions of chips, miles of wire, and tons of plastic coming together at breakneck speeds to meet the holiday deadline.
They have changed how we decorate, turning static displays into dynamic, personalized light shows.
And best of all, you'll never again have to spend Christmas Eve hunting for that one dead bulb that killed the whole strand.
Are you embrace the smart light revolution, or do you stick to the classic traditional strands? Let us know in the comments below.
If this look inside the future of holiday lighting bridled your day, hit that subscribe button. Happy holidays from In the Factory.